Fundamental theorem of calculus, part 2. If f is continuous over the interval ab and capital F of x is any antiderivative of f of x, then the integral from a to b of f of x with respect to x equal capital F of b minus capital F of a. So basically, we need to find the antiderivative of the function f of x and then evaluate at b and a and subtract the difference. So usually we will write out the integral to be this way. So we find the antiderivative in terms of x. Then we put a line right here saying we evaluate at b, subtract a. Then we write f of b minus f of a. So it's easier that way. So let's take a look at this example. Integral from 2 to 7, fourth root of y cubed dy. Now it doesn't matter what letter you have in here. You can use it as x, you can use it as y. What it's telling you is just to find the antiderivative of this function and then evaluate from 2 to 7. In another word, a definite integral is always a number. It always gives you a number back. So the first step is to write everything in power. Okay, so it's from 2 to 7, y to 3 over 4 power. So any root is a fraction. Okay, so fourth root is 1/4. So 3 over 4 power dy. And then the next step is to find the antiderivative of y to the 3 over 4 power. So using the power rule of antiderivative is y to the power increased by 1. So 3/4 plus 1 is 7/4. And you divide it by the same power. 7/4. And then you evaluate at 7 and then you subtract it at 2. So what it is, okay, so you're dividing by a fraction the same as multiplying by the reciprocal. So it's 4 over 7. You plug in 7, okay, 7 to the 7th power and then the fourth root. And then you subtract 4/7 fourth root of 2 to the 7th power. And you can just leave it this way.